Let's do a quick demo on the class CS101Grade that we have just described. The class is already open in the Bootstrap environment. As you can see, this gives the same definition for CS101Grade as we have seen in the lecture. Here is the declaration of the class variables. Notice the keyword statics here, and the declaration of the instance variables. Here is the declaration of the constructor with one parameter, which assigns the parameter name to the instance variable student name. In the demo, I'll invoke the method setScore, which obtains scores for exam score, lab score, and homework score. I'll then invoke the method setFinalGrade to compute the weighted sum of the scores. Notice that setFinalGrade will call compute grade with the instance variables exam score, lab score, and homework score. Notice also that in the definition of compute grade, the parameters exam score, lab score, and homework score use the same set of names as the instance variables. But as described earlier, the parameter variables would be allocated different memory spaces. Let's compile the program. Good, there's no error. I'll also set a breakpoint here inside the compute grade method so that we can examine the computation of the weighted scores more carefully. We can create an instance of CS101Grade by right-clicking on the icon and then select the only constructor here. Let's create an instance for myself by entering TC and close in double quotes. And you see the instance created in the object bench. Let's open the inspector window, and you'll find that the instance variables have been initialized to 0. We can set the scores using the setScore method. Let's enter 90, 80 for lab grade, and 70 for homework grade. And you can find in the inspector window that the value of the instance variables have been updated to the corresponding values. Now let's invoke the setFinalGrade method to compute the final grade. A debugger window is popped up since we have set a breakpoint inside the compute grade program as indicated here. Notice that in the debugger window, there are 3 sets of variables: the statics or class variables, the instance variables, and the local variables. Although the instance variables and local variables are given the same names, exam score, lab score, and homework score, they are given different memory spaces. When we step through the execution, the first statement is to compute the weighted score for exam score. You'll find that only the local variable, exam score, is updated, but not the instance variable. Instead of getting 63 as expected, the value is displayed as 62.99999 because of the imprecision in floating point number representation. If we continue the execution, the local variable for lab score is now updated, but not the instance variable. Similarly, homework score is updated while the value of the instance variable stays the same. Compute grade would then compute and return the sum of exam score, lab score, and homework score. Notice that if the local variables are used in the computation, the result of adding exam score, lab score, and homework score would be 86. But if the instance variables are used, the result of adding exam score, lab score, and homework score would give a value of 240. You'll find later that the local variables were used and the value of 86 was returned. Let's carry out another step of the execution. Notice that when the program exited compute grade, the local variables no longer exist, and the return value of compute grade is assigned to final grade in the setFinalGrade method, and the value is 86. If you check the inspector window, the instance variables remain the same, while the final grade has been computed to 86. I'll show you next the effect of giving the parameters different names. Let's try to rename the parameter exam score to X, lab score to Y, and homework score to Z, and make the corresponding changes inside the method by changing all appearances of exam score to X, lab score to Y, and homework score to set, and create the instance again, and use the same set of scores. When set final grade is executed, you'll find in the debugger window that the local variables are now given different names, x, y, and z. When you step through the execution, the process is the same as before. The local variables are updated, and the return value is the same, 86, while the instance variables are not affected. An analogy of using different names for the parameter is like using a different set of containers for the exact same amount of ingredient for a recipe. It shouldn't affect the end results. Let's make one more modification by replacing the name of the variable on the right-hand side of the assignment statements by the name of the instance variables. That is exam score for x, lab score for y, and homework score for z. We'll do the same for the return statement. An instance is created like before. The same set of scores is used. When set final grade is executed for this instance, you'll find that the instance variable exam score is now changed because this is the only place that the program can find the name exam score. Similarly, the instance variable lab score and homework score are also updated. Although the return value for final grade 86 is the same as before, the values of the instance variables have been changed. This could be a problem if you want to retrieve the original scores later. Let's go back to the lecture video to explain this in more details.